meron din tayong environmental appraisal of highway schemes. Sa pagpaplano ng highway project, kinoconsider din ang environmental appraisal kung saan nagkakaroon ng public consultation and environmental assessment para malaman yung possible na maging impact ng gagawing proyekto. Noong una, hindi siya included sa highway planning, but the US originally had this procedure started way back here 1960s when environmental issues gained importance. The process was made statutory under the National Environmental Policy Act 1969, which requires the preparation of an environmental impact statement for any environmentally significant project undertaken by the federal government. So, yung inassess dito sa NEPA ay yung the probable environmental impact ng proposal, yung mga hindi may iwasang epekto ng proyekto sa environment, alternative options to the proposal, short-run and long-run effects of the proposal, and any irreversible commitment of resources necessitated by the proposal. In the following year, kinonsider na din ng Europe ang pagkakaroon ng environmental impact assessment in response to the perceived shortcomings within the then existing procedures for assessing the environment consequences of large-scale development projects and for predicting the long-term direct and indirect environmental and social effects. The advantages of such a procedure was noted by the European Commission, and the contribution of the EIA to proper environmental management was noted in the Second Action Program on the Environment published by them in 1977. Particularly in UK, meron silang sariling format sa pag-assess ng environmental impact of the proposed highway project since 1993, which was written in the Design Manual for Roads and Bridges. Dito, meron silang in-identify na 12 environmental impacts na kanilang in-assess and ginawang basis sa magiging decision nila regarding the highway proposed project. So, the 12 environmental impacts forming the assessment framework are: first ay air quality. Dito, tinitingnan yung magiging epekto ng mga gases na pinoproduce ng sasakyan like carbon monoxide, oxides of nitrogen and hydrocarbons, lead, and carbon dioxide sa environment. The next is the cultural heritage. Then the construction disturbance like dirt, dust, noise, and vibration na nakikreate habang ginagawa ang project. Fourth is the ecology or nature conservation. The highway being proposed may negatively affect certain wildlife species and their habitats. Therefore, it is being considered also. Landscape effects, land use, traffic noise and vibrations, pedestrian, cyclist, and community effects. The severance of communities and its effect on people in terms of increased journey time and the breaking of links between them and the services of or facilities used daily by them, such as shops, schools, and sporting facilities, are evaluated within this category of impact. Vehicles travelers. This assess the proposal from the perspective of those using it, for example, the drivers. Water quality and drainage. This measures the effect that runoff from a road development may have on local water quality. Geology and soils. Lastly is the policies and plans. Pero mayroong iba dito na pwedeng ma-estimate yung impacts qualitatively. So next we have the new approach to appraisal or NATA. Next, we have the new approach to appraisal. During the late 1990s, the UK government reviewed its road program in England and identified those strategically important schemes capable of being started within the short to medium term and listed them as potential candidates for inclusion within a targeted program. Each of these schemes was subjected to a new form of assessment that incorporated both the COBA-based economic appraisal and the EIT-based environmental assessment. This methodology, called the New Approach to Appraisal, or NATA, includes a one-page summary of the impacts for each of the projects considered. Within the method, all significant impacts should be measured. Wherever possible, assessments should reflect the numbers affected in addition to the impact on each. It is desirable that all impacts be measurable in quantitative terms, though this may not always feasible. So makikita ito sa table. Yan. Categorize lang nila yung naunang basis ng assessment, which in the environmental impacts, kasama na yung noise, air impacts, landscape, biodiversity, heritage, and water. Sa economy ay under naman niya yung journey times, cost, journey time, reliability, and regeneration. Yung mga pedestrian, access to public transport, and the community severance ay sama-sama naman dun sa accessibility. Meron din na safety at saka integration. So, the next topic is about the basic elements of highway traffic analysis. In this topic, we are going to discuss the different parameters used to measure the level of effectiveness of the highway and also the relationship to each other. So, we have certain parameters associated with highway, and these are the quantity of traffic, the type of vehicles within the traffic stream, the distribution of flow over period of time, usually 24 hours, the average speed of the traffic stream, and the density of the traffic flow. Why do we need to measure and analyze these parameters? It is to ensure the safety and efficiency of a highway to be constructed. So, para malaman natin yung relationship between these parameters, we have the equation traffic flow Q is equal to the product of speed U and the traffic density K, where Q is expressed in vehicles per unit time. Nag-come up tayo sa equation na to from these three equations. So, sinubstitute lamang natin sila para makuha yung Q is equal to U times K. Yung traffic flow Q ay dinimeasure ang value ng traffic on a highway. Dinedetermine natin ito base sa number ng vehicles N passing in a given point on the highway at time interval T. Kaya meron tayong first equation na Q is equal to N over T. Pero pwede natin makompute yung number of vehicles on a given section of highway in terms of the density of concentration of traffic that leads us in the second equation, N is equal to K times L, where the traffic density K is a measure of the number of vehicles and occupying a length of roadway L. Substituting the second equation to the first equation, we have Q is equal to K times L all over T, in which L over T is the speed. So, under ng speed flow density of a stream of traffic, meron naman tayong speed density relationship, flow density relationship, at speed flow relationship. Mavi-visualize natin sila through these linear models. Una ay itong speed density relationship. So, paano sila connected sa isa't isa? Inahalin tulad ko siya sa movement ng particles. Di ba kapag madaming space between the particles, they can move freely. Likewise, kapag isa lang yung nagtatravel sa kalsada, freeing magpatakbo yung driver ng mabilis. Ina-consider natin na zero na yung density kapag ganon, and the speed is termed free float speed. At habang nag-i-increase yung density, nag-decrease naman ang speed na dapat mayroon ng isang sasakyan. Kapag nasa maximum na yung density, which means the spacing between the vehicles is minimum, and that is under jam condition, the speed is nearly or already zero kasi nga wala na masyadong nagiging movement yung mga sasakyan kapag onti na lang yung space between them. Kasunod is yung sa flow density relationship. So, meron tayo ditong linear model na nagpapakita noong relationship nila sa isa't isa. Para malaman natin yung mathematical relationship ng flow and density, we have these two equations. Yung combining them, we get this. So, yung naunang equation dito is dinerive siya. Then, yung inequate sa zero yung dq over dt para makuha natin yung maximum flow. Yan. Kaya, nagkaroon tayo ng k sub m is equal to k sub j over 2. Yung meaning, yung density at maximum flow, km, is equal to the half of the jam density, kj. So, we have the speed-flow relationship. Parabolic din siya tulad ng flow-density relationship. So, para ma-express natin yung relationship between speed and flow, meron tayong equation na ito. So, kinombine sila, kaya nagkaroon dito ng q is equal to k sub j times u minus u squared all over u sub f. So, dinerive din both sides and equating dq over dt to 0 para makuha yung speed at maximum flow. Therefore, nakakuha tayo nung final equation na u sub m is equal to u sub f over 2. Combining all these equations, yung kanina na k sub m is equal to k sub j over 2 and u sub m is equal to u sub f over 2, this expression for maximum flow is derived. So, q sub m is equal to q sub f times k sub j is all over 4.